Okay guys, so we're going to talk about components of vectors, and I think the first question that we should address is, why are we going to go through all this? We've already learned how to add vectors together graphically using a ruler and a protractor, and although this works and it works just fine, it would be nice to have a method that is more mathematical in nature that will allow us to use a calculator without the need to use rulers and protractors, because it takes a while. So what we're going to do is we're going to take advantage of some properties of vectors so that we can use our right angle trig in order to break them down into a form that will be more useful to us. To show you what I mean by this, we will take a vector, say it's a velocity vector of 150 meters per second. Let's make that last zero significant as well. And this vector is pointed at an angle of 35 degrees north of east. So looking at that vector, we can view it as a resultant of two other vectors. And the two vectors that we can choose any two vectors, but it's going to be very convenient for us to think of this in terms of the resultant of two vectors, where one points along in the x direction, and we'll call this the x component, and the other points along the y-axis, and we will call this the y component, for obvious reasons. The other thing we have to do is we have to define a coordinate system to determine which direction is going to be positive. So I'm going to choose that to the right will be positive, and then in the other dimension I'll choose up is positive. Now this is arbitrary. I could have just as easily picked that to the left is positive. I could have also picked that to the down is positive, that going down is positive. The way we choose the positive direction, it's still up to the problem and what we have to do in that problem. But in this case, usually this is the direction that that we'll consider positive. Now, back to these components. The reason why we chose the x and y components instead of two other vectors is that they're at right angles to each other. And therefore, because they're at right angles to each other, we can use right angle trigonometry to figure out what values that they would have. So once again, the idea behind this is we have a velocity of 150 meters per second at 35 degrees north of east. Okay, that is the velocity that actually exists. That's the vector that actually exists. But the mathematical trick we can use is to say that 150 meters per second at 35 degrees north of east is actually the addition of two other vectors, or it can be viewed as the addition of two other vectors, an x component and a y component. So to get the values of these, we will use right angle trig, and we can say that the y component, to find that, we say that the sine of 35 degrees is equal to our y component over hypotenuse of 150 meters per second, and therefore our y component, rearrange that a little bit, will be equal to the sine of 35 degrees times 150 meters per second. You punch that into your calculator, make sure you're working in degrees, and you'll get 86.04. I'm going to put a line down here just so we know that those are not sig figs, but it's a good idea to carry extra figures along until the end of your calculation. For the x component, we'll do something very similar, except now this is the side adjacent to the angle, and so we'll say that the cosine of 35 degrees is equal to our x component divided by our hypotenuse of 150 meters per second, and our x component, again rearranging a little bit, will be the cosine of 35 degrees times 150 meters per second, and that gives us 122.87, again carrying some extra sig figs here. So this 150 meter per second vector, this velocity vector, can be seen as the addition of a vector pointing along the x-axis with a magnitude of 122.87 meters per second, and a vector pointing up along the y-axis with magnitude 86.04 meters per second. Now, you have to be careful when you break things up into components that you make sure you get your signs right. In this case, this vector had a positive x component because the x component pointed off to the right. It also had a positive y component because the y component pointed up. What if we had a vector instead that was 75 meters per second, so now we have a velocity of 75 meters per second, and it was oriented at 43 degrees north of west. Okay, once again, we'll think of this in terms of components. What two vectors can we add together to get that vector? And once again, it'll be convenient to choose an x component and a y component because they're at right angles. And so in this case, the x component will point off to the left. So this is going to be my x component. And my y component will be pointed up. Okay? Now, we'll keep the same coordinate system that was we did in the previous problem, just to illustrate a point here. And that is, if my x component is pointed in the negative direction, I will need to include that myself. There's nothing in the math that will put a negative sign in there, but the x component is pointing in the negative direction. Since we defined to the right is positive, to the left has to be negative. And so the x component will now be equal to negative cosine of 43 degrees, because again we're dealing with the side adjacent, times the hypotenuse of 75 meters per second, which gives us negative 54.9 meters per second. So again, I emphasize you need to include this negative sign yourself, and you're going to just have to keep control of that. Draw pictures. Okay, whenever you do a vector problem, you should always draw pictures of the vector and of the components to help you keep things straight as far as what direction it goes. For the y component, because it is the side opposite, will be sine of 43 degrees times our hypotenuse of 75 meters per second. And it is pointing up still, which is a positive direction, so this will be a positive number still. And this will be 51.2 meters per second. Okay, so once again, when we break vectors up into components, the reason why we're doing it is it'll allow us, as we'll see in the next lecture on vector arithmetic, it'll allow us to add vectors together. Okay, so that's why we're doing this. We pick the x and y components, so the x and y directions, because they are at right angles to each other, which makes the trig a lot simpler. And always make sure that you define your coordinate system and that you are consistent with that. So if something is pointing in the negative direction, make sure you put a negative in front of that component when you work the problem.